But let's start with a little bit of history. Christian Birkeland was born on the 13th of December 1867. He was a Norwegian scientist who became fascinated by the aurora borealis, and he postulated that the sun's electrical discharges travelled across space and caused the phenomena back on Earth, and he conducted detailed experiments to test this hypothesis. In 1903, his experiments found electrical currents flowing parallel to the aurora formation. Now, as currents must always flow in a closed loop, he proposed that the currents must flow down from space and then back out again. Most scientists at the time disregarded his experiments, not believing that these charged particles could travel from the Sun all the way back to Earth. And it was much more recently that it was actually rediscovered by NASA, who now call this the aurora electrojets, but it is exactly what Birkeland had speculated and discovered. In 1967, Dr. Alex Dessler discovered these electric currents in space, and he actually named them after Birkeland, and this is where the term Birkeland currents come from. These auroral Birkeland currents carry about 1 million amperes and can heat up the upper atmosphere, causing increased drag on satellites. Now, before we move any further, it is important to understand some very basic concepts about plasma. Plasma is defined as an ionized state of matter. Plasma can operate in three very distinct modes. The first one is called dark mode, and here the plasma has a very low current density, a low electric field, and it is not in an excited state. It's not visible and it's extremely difficult to actually detect it. An example of this would be our own ionosphere, where we actually use the ionosphere to bounce radio waves off so that you can actually hear radio all around the world. Now, the second mode is called glow mode, and here the plasma becomes more excited and starts to glow. The current density is increased as the electric field starts to drop. An example of this includes neon signs and also the sun's corona. Now, the final mode is called arc mode, and here the current density continues to increase as the electric field drops, and the temperature of the plasma increases and arc discharge takes place. And this can either be in the form of arc lightning or what they call an arc flame.